Good morning, students. Today we are going to start with the last part of your chapter number 1, Matter in Our Surrounding, that is part 7. Let's have a look on the topics what we have studied in last class, that is evaporation, what is its cause and what are its effects. Today we are going to continue with the same topic with factors affecting evaporation. Now, before we will start about the factors, let us have a look once again that what is evaporation and what is the reason how the evaporation process occurs. What is evaporation? It is process to convert a liquid into vapor below its boiling point. That is called evaporation. Now, see how the process of evaporation occurs with the help of this flow chart. When we start heating a liquid, then the intermolecular force of attraction between the particles that start decreasing. The particles gain high momentum and they start escaping the liquid as steam, and thus the process of evaporation occurs. Now, factors. There are 4 factors which affect the process of evaporation. Number 1, temperature. Number 2, surface area. Number 3, wind speed. And number 4, humidity. Now let us start with the first factor, that is temperature. Temperature of the substance. If the temperature of a substance is more, then evaporation will be faster. Because what happens when the temperature becomes high, the more energy to the molecules is provided by the system, and then these molecules change their state. Hence, in the other words, we can say that evaporation is directly proportional to the temperature of the evaporating surface. Warmer the evaporating surface, higher will be the rate of evaporation. You can understand this factor with the help of the diagram given below, that if a solid is kept, that is a piece of ice is kept at the room temperature, then it will start melting first, and after some time, if the temperature will keep on increasing, then we will obtain the vapors of the water. Second factor, that is surface area. You already know that evaporation is a surface phenomena. The rate of evaporation is determined by the area of the exposed surface of water. Larger area of evaporating surface, evaporation process increases. A larger surface area allows more molecules to leave the liquid and the evaporation becomes faster. Have a look at these 2 examples given below. Suppose we will take 10 ml of water in a test tube and the same 10 ml of water in a beaker or in a china dish, and keep them for the process of evaporation. We will observe that the water from the china dish or the beaker will evaporate faster than the water kept in test tube. The reason is obvious, that the surface area of the beaker is more than that of the test tube. Now have a look at the second example, that whenever you want to get your clothes dry and you take them out from your washing machine, then you spread them properly in the sunlight to get them dry. If you will leave them crumpled and put them on a wire to get them dry, obviously they will take more time. So what is happening over here? The surface area of the clothes will become more, so the process of evaporation also becomes faster and they get dry faster. Third step of factor, that is wind speed. Molecules in motion have more energy than at rest, and so the stronger the flow of air, the greater the evaporating power of the air molecules will be. Example is clothes dry up faster on a windy day. Fourth factor, that is humidity. What is humidity? Amount of water vapor in the atmosphere is known as humidity. The rate of evaporation is closely related with the relative humidity of air. The moisture holding capacity of air at a given temperature remains limited. Drier air evaporates more water than the moist air. It is a common experience that evaporation is greater in summer and at midday than in winter and at night. When humidity of air is low, then rate of evaporation will be high, and when humidity of air is high, then the rate of evaporation will be low. With this, we have completed chapter 1. In next class, we will revise this chapter and discuss the questions of the NCERT. Till then, thank you.